I'm Rodger Kram. I'm a professor here at the University of Colorado Boulder. I operate the locomotion lab, and we study how people walk, run, and ride bikes. We wanted to develop the gravity-based treadmill method so that we had a gold standard for measuring the power output. The power that you apply to the cranks can either overcome gravity or overcome aerodynamic forces. It doesn't matter. Power is always going to be equal to force times velocity. I prefer this method because it's physics-based. The gravity-based treadmill method exactly replicates the way a real human applies torque to the pedals and cranks of a bicycle, because it is a real human turning the pedals in this testing. The alternative method is to use a motor-driven dynamometer, which applies a constant torque throughout the crank cycle. No human pedals that way. It doesn't require special equipment. It could be tested, it could be applied anywhere in the world as long as you have a big enough treadmill and an accurate inclinometer to measure the angle of the treadmill. We like our method better because it's more like a real rider is going to use their power meter when they're out on the road. Other companies have their own testing protocols and they make their own claims, but 4i came to me and said, we want you to objectively test our power meters and tell us what the numbers are. They took those numbers and they went back to the drawing board and improved their product. I hope that other power meter companies also come to me and that we can become the standard testing lab for the industry. We'd be happy to do that, and we think that we're objective and we know that we're careful and precise. We've used this method to test pedal-based power meters. We've used it to test crank spider-based power meters. We've used it to test hub-based power meters. And in fact, with our method, you could also put the power measuring pedals on power measuring cranks and put a power measuring hub on the back wheel and measure all three at once. This method can be used anywhere in the world because gravity is basically the same anywhere in the world. Another advantage of the treadmill testing is that it's replicatable. So what we have done in the past is to simulate outdoor temperature fluctuations. We've had people ride on a bike with a set of power measuring cranks at room temperature, and then we take the cranks off and put them in the freezer for an hour and have lunch. We put the cranks back on and measure the power. We can simulate riding outside in freezing conditions. Then we took the cranks off the bike and we put them in a styrofoam box and poured hot lead pellets over the cranks until the cranks got up to 130, 140 degrees Fahrenheit. And then we took them out and rode the bike as quickly as we could. So we could simulate how fluctuations in temperature affect the accuracy of the power meter, but we were doing it in controlled conditions. Whereas if we were outside, we couldn't control the power demand of riding outside because the wind might change and we wouldn't be able to actually have a gold standard for the power that was being put in.